Hi everyone, welcome to section 10.5 where we explore our last law for solving triangles. This section focuses on something called the law of cosines, and we need another law because sometimes when we are given information in order to solve a triangle, we're not necessarily given an angle and side opposite. So when we are given an angle and a side opposite, we know of course we can use the sine law, but what happens if we're not given an angle and a side opposite? In those cases, what we need to use is the law of cosines, and you see several different variations for the law of cosines at the very bottom of the slide here. But one thing I want to make very clear before we move forward is that if you can figure out the orientation of the triangle information that you're given, so if it happens to be side angle side, which means two sides in the angle between those two sides, or if you are given three sides, then these scenarios will lend themselves to use the law of cosines instead of the law of sines. So once again, if it's SAS, so side angle side, or SSS, it's three sides given for given information, then you're going to use the law of cosines. So this may be a really easy way for you to figure out which law to use moving forward. Now, if I focus on just one version of this cosine law, because there are three different formulas associated with this law, if I focus on one version here, it says a squared is equal to b squared plus c squared minus 2 times b times c multiplied by the cosine of angle A. So with this formula, it's really important to remember that lowercase letters represent side lengths and uppercase letters represent angle measurements. So another thing I'd like for you to notice is if you have angle A, for example, you're going to be dealing with an a squared formula. If you have angle B, then your formula will start with b squared. So again, just one more example of our law. You've got b squared, which is equivalent to a squared plus c squared minus 2ac multiplied by the cosine of angle B. So again, the side length and the angle that correspond with the same letter are in the same formula. So there are three different versions of the cosine law, and we're going to show you how to make substitutions and solve for different pieces. So in our first example, it says solve triangle ABC with B measuring 10 centimeters, C measuring 20 centimeters, and A measuring 30 degrees. So the first thing we'd like to do here is actually make a sketch. I really don't know if this is an acute or an obtuse triangle, so your sketch is really kind of vague. In this case, we were given angle A measuring 30 degrees, so I'm just going to say this might be angle A, and I'm going to put that measurement in place as 30 degrees. I know I have side length B and side length C, so if I call this part C, let's say, or angle C rather, and this angle B, this might be a reasonable depiction of our triangle, but we're really just not sure. So B measures 10 centimeters, and I know that happens across from angle B, and side C measures 20 centimeters, so it happens across from angle C, of course. So what we recognize here is that we do have two sides and the angle sandwiched between those two sides. So this angle connects our sides B and C, so we can see for sure that this is an SAS triangle. So you have two sides in an angle, and the angle is actually between those two given sides. So because this is an SAS orientation, we know for sure that we must use the cosine law. If we wanted to use the sine law, we would have to have an angle and a side opposite. We don't have the side opposite 30 degrees, so the sine law wouldn't get us anywhere at this stage. So what we want to do is build our table. A has been given as 30 degrees. We don't know side length A, so we'll leave that blank. Angle B is not given, and angle C is not given. We know that side length B measures 10 centimeters, and we know side length C measures 20 centimeters. So we're looking for several pieces of information. Now, in order to start with cosine law, if you recall what those cosine law components are, we know that we need to have an angle if we're not calculating an angle. So the version of the cosine law that I'm going to start with here is the a squared version. So a squared will equal b squared plus c squared minus 2 times b times c multiplied by the cosine of angle A. The reason why I want to use this version of the cosine law is because I have angle A. I have 30 degrees in place, so I know I can make a substitution. I also have side length B and I have side length C. So what this version of the cosine law is going to allow me to do is solve for side length A. So keeping that in mind, now this just becomes an exercise in substitution. So we know that a squared is an unknown. We're going to solve for that. B squared means we have 10 squared plus c squared, or 20 all squared, minus 2 times b, so 2 times 10, times c, or 20, multiplied by the cosine of angle A. And we know angle A measures 30 degrees. Now it's up to you the number of steps you want to take in order to do this calculation. If you are very mindful of brackets and your operations, you can actually type this in all at one time. If you're not so comfortable doing that, you can do this in smaller steps. Take a moment to work out the right side of your equation. What you should have for an a squared value is approximately 153.59 if we round to the nearest hundredth. So it doesn't mean that side length A measures 153 centimeters. What that means is that's a squared. So we need to square root that answer so that we get instead the square root of 153 approximately. So let's just write that out as our step. So A gives us roughly 12.4 centimeters if we round to the nearest tenth. So we've got 12.4 centimeters for side length A. And at this stage, we're ready to solve for the other two missing angles. So if I want to solve for angle B, next, let's say we want to go alphabetically, then the version of the cosine law that I must use has to have b in it. So the version of cosine law that has b in it would start with b squared on the left side. So b squared will equal a squared plus c squared minus 2ac multiplied by the cosine of angle B. Now just be mindful that you will be given a formula sheet to work with, so you don't have to memorize these laws, but you will be practicing with them over and over again. So B squared means we have 10 as our B value. Of course, we'll have 10 squared is equal to A squared. Now we have to use information that we calculated, so we're going to use 12.4 all squared plus our C squared value, so 20 squared minus 2 times A, which we know is 12.4, multiplied by C, which we know is 20. Then we multiply that by the cosine of B. So we don't know B. That's the part that we're kind of trying to manipulate and solve for. So let's just take a look at how we can manipulate this equation. Some students like to work some of these values out in advance, and you're welcome to do that, of course. But I'm going to show you how to manipulate this equation and solve for the cosine of B. So if I want everything shifted to the left with the exception of cosine B, the first step I'm going to take is to actually subtract 12.4 squared. Whoopsie, there we go. I'm going to subtract 12.4 squared from both sides, and I'm going to subtract 20 squared from both sides. So then we'll get 10 squared minus 12.4 squared minus 20 squared, and that's going to be equivalent to negative 2 times 12.4 times 20 multiplied by the cosine of angle B. So again, if you're not comfortable manipulating these terms, you can do those calculations and start combining those values. So from here, if I wanted to solve once again for cosine b, I am multiplying cosine b by -2, 12.4, and 20. So I can divide the left side by those terms. So I'm dividing by -2 times 12.4 times 20, which means I must do the same thing on the opposite side. So you've got -2 again times 12.4 multiplied by 20. So do these calculations in as many or as few steps as you like. But what I want you to be very mindful of is if you're going to type this into your calculator in one step, you want to make sure that anything that's in a numerator has one large set of brackets on the outside, and anything that's in the denominator has a large set of brackets on the outside. Because if you don't separate those with brackets, it will not divide the proper terms and you'll get a very different answer. So what we want to do is, again, break this up into smaller calculations if you're more comfortable, or be very mindful that you need to use brackets when you type this into your calculator. If you're careful, what you get on the left side is approximately 0.9148. And we want to make sure we round pretty far because this is a ratio. This is telling us the cosine value for angle B. Now, if we want angle B itself, we know we have to use an inverse function. So B on its own is going to be cosine inverse of 0.9148. So you're going to have to use that second function on your calculator. So again, double check that you're still in degree mode, of course, but we want to make sure that we're using cosine inverse of that decimal 0.9148. When you do, what you get for a B value is approximately 23.8 degrees. So I can fill that back into my chart and say that must be 23.8 degrees. So far, everything aligns because we have an angle of 30 degrees across from a side length of 12.4 centimeters, and we have a smaller angle of 23.8 degrees across from a smaller side of 10 centimeters. So to solve for that third angle, you have several choices. You can use the cosine law to solve for angle C, or you can use the strategy that we know all three angles will sum to give us 180 degrees. So we could subtract. Now, just for extra practice or for additional practice, we're going to use the cosine law to solve for angle C. Again, you don't have to, but this is a good way for us to verify that our answers are correct. So if I wanted to find angle C now, then I need to use the version of the cosine law with angle C in it. And that one starts with C squared. So C squared will equal A squared plus B squared minus 2AB multiplied by the cosine of angle C. So C squared means we'll have 20 squared on that left side. That's going to equal A, or 12.4 all squared, plus my B value of 10 all squared, minus 2 times 12.4 times 10, multiplied by the cosine, again, of angle C. So this is going to require manipulation. We're going to take that 20 squared and subtract 12.4 squared to move that term over to the left. We're going to subtract 10 squared, again, to move it over to the left. And we know that'll be equivalent to -2 times 12.4 times 10 times the cosine of angle C. So again, our last step to solve for cosine C at least will be to divide both sides. And when we divide, we need to divide by -2 times 12.4 times 10. So we carry out that plan. We've got -2 times 12.4 times 10. So we carry out that plan and work out our division for cosine C. Again, be mindful that you want to put brackets around the numerator and denominator separately, but if you type this in correctly, you'll get approximately -0.5897 as your cosine C value. So to get the angle itself, we know we have to take cosine inverse of that decimal number. So when you do that, when you find cosine inverse of that ratio, we get an angle value of approximately 126.1 degrees. So when we put that into place, 126.1 degrees, what we can do is sum those together. So if you added 126.1 and you added 23.8 degrees and another 30 degrees, we get 179.9 degrees, which is close, but the reason why we're off is because we've used approximate values. 12.4 centimeters was an approximate value. The angles that we're using, once we calculate them, are approximate values, so you could be off by a tenth or so, and that's perfectly reasonable. So we have now solved this triangle. We found all missing sides and we found all missing angles, in this case using the cosine law. Now our last triangle happened to be an obtuse triangle. It had an angle in it larger than 90 degrees, but we're just never really sure. So don't worry if your sketch doesn't necessarily match what you get as a final result. So the next triangle we want to solve, number 2 here, says we're given triangle ABC with side lengths A, B, and C measuring 9, 12, and 15 meters. When we look around those three sides. So again, I'm not 100% sure what type of triangle we have, but if I want to make the largest side, in this case 15 meters, so I'm just going to try and draw it reasonably accurate with my sketch. So that'll be across from angle C. My next largest side will be side B, so I'm going to call this my side length for B. And then my third side, side A, is the smallest side. So I'm going to call that my side length for A. So we're actually looking for 3 different angles in this scenario. We want angles A, B, and C, even though we're given 3 sides. So again, with this triangle orientation, it's very easy for us to say that this is an SSS triangle. So again, fill in your chart so you can keep your information organized, and in the end do a bit of a check to make sure that things make good sense. So from here, if we want to start alphabetically and solve for, let's say, angle A, we know that the version of the cosine law we have to use starts with a squared. So a squared will equal b squared plus c squared minus 2bc multiplied by the cosine of angle A. When you're doing these kinds of questions for assessment, so if you're doing this on a quiz or a test, I want to see where you have made your substitutions so that we can see if maybe, if you do happen to have a wrong answer, maybe it's just a small calculator mistake. So if you show me your substitutions and how you've manipulated your equations, even if there's a small calculator mistake, you can get majority marks. So now let's substitute what we know. We know A is 9, so we've got 9 squared. B is measuring 12, so that's going to be 12 squared plus our c squared value, which is 15 all squared, minus 2 times 12 times 15, that's our B and C once again, multiplied by the cosine of angle A. So if we manipulate this, we're going to subtract 12 squared from both sides and 15 squared from both sides, and that will leave us with negative 2 times 12 times 15, multiplied by the cosine of angle A, and of course we need to divide now. Divide both sides by negative 2 times 12 times 15 in order to isolate for that cosine of A. So then we'll have 9 squared minus 12 squared minus 15 squared all contained in the numerator, and we're dividing that by negative 2 times 12 times 15 in that denominator, again contained, to give us the cosine of angle A. What we get for a decimal number is 0.8. So 0.8 is the cosine of angle A. So A on its own is cosine inverse of that decimal 0.8, or that ratio. So angle A, when we do our calculation, is roughly 36.9 degrees if we round that to the nearest tenth. So we can put that into our chart and know that we've solved for one of our missing 3 parts. Now, if we keep working alphabetically and we want to solve for angle B, we have to use the formula that starts with b squared. So b squared will equal a squared plus c squared minus 2ac multiplied by the cosine of b. So once again, b is 12. We've got 12 squared That's equal to 9 squared plus our c squared value of 15 all squared minus 2 times 9 times 15 multiplied by the cosine of angle B. So we subtract. We've got 12 squared minus 9 squared minus 15 squared, and ultimately we will divide. So we've got negative 2 times 9 times 15 multiplied by the cosine of angle B on that right side. So if we were to solve, we would contain that numerator and contain the denominator because we will ultimately divide by negative 2 times 9 times 15 to give us our cosine B value. Once our calculation of that left side is complete, we get 0.6 for our cosine B ratio. So B is going to be cosine inverse of 0.6. And what we find for angle B is that it's approximately 53.1 degrees. So we can go back and fill that into your chart. Now you have two options to solve for angle C. You can use the third version of the cosine law. So c squared equals a squared plus b squared minus 2ab times cosine of c. So that's a great way to make sure your information is on the right track. Or we can take the shortcut and say 180 degrees, well, angle C is going to be 180 degrees minus the two calculated angles. So we're going to subtract 36.9 degrees and we're going to subtract 53.1 degrees. What you find in this case, whether you use the cosine law or just subtraction, is we actually get a C value of 90 degrees. What that means is this is a right triangle, even though we had no clue maybe from the beginning that this was a right triangle. So if you have a right triangle, we can use SOHCAHTOA, so sine, cosine, tangent ratios, or we could use Pythagoras' theorem to solve. But again, because we didn't know for sure right from the beginning, we have to use sine law or cosine law. And in this case, because we were given three sides, cosine law was the necessary law for us to be utilizing. Once again, we've been able to find all three angles, which were the three missing parts in order to solve this triangle. So in our last example, we want to solve triangle ABC with A measuring 55 centimeters, B measuring 25 centimeters, and C measuring 72 centimeters. Once again, I have no clue whether this is an acute, an obtuse, or a right triangle, so I'm just going to draw a very general triangle. My longest side is 72 centimeters, so I'm just going to label it that way, and that's across from angle C. My second largest side is A, so I'm going to label it with A in my left corner, measuring 55 centimeters across from that angle, and angle B will be across from 25 centimeters. So what we have here are three sides. Again, we know cosine law is used for SAS or SSS, so I kind of think of the word SAS. If you hear the word SAS, if it's SAS or SSS, then we know it's a cosine law triangle. So here, we're missing all three angles again, and I'm going to use approximation symbols because typically we're going to have to round those values. Side length A is 55 centimeters. Side length B is the longest side, so we should anticipate, oh no, rather, sorry, B is measuring 25 centimeters, so that's the smallest side. So it should be across from the smallest angle. C measures 72 centimeters, which is the largest side. So again, should be across from the largest angle. So let's just go alphabetically once again. We can solve for angle A, which means we have to use A squared equals B squared plus C squared minus 2bc multiplied by the cosine of angle A. So A squared is going to be 55 all squared. That's equivalent to B squared or 25 all squared plus C squared or 72 all squared minus 2 times 25 times 72 multiplied by the cosine of angle A. So we still manipulate the equation the way we did before. So we've got 55 squared minus 25 squared minus 72 squared set equal to negative 2 times 25 times 72 multiplied by the cosine of angle A. And then we, of course, divide. So we'll have 55 squared minus 25 squared minus 72 squared, all divided by negative 2 times 25 times 72. And if we bracket that properly, we'll get an accurate answer for the cosine of A. So if you take your time with your calculation, you should get approximately 0.7733 as your cosine A value. So of course, A is going to be cosine inverse of that decimal. So 0.7733, when we use cosine inverse, gives us an approximation for angle A measuring 39.3 degrees. So we can fill that into our chart, knowing that we now only have 2 more angles to complete. So if we want to find angle B, the version of our cosine law must start with b squared. So b squared will equal a squared plus c squared minus 2ac times cosine of angle B. So now we make those substitutions carefully. So 25 squared will equal 55 squared plus 72 squared minus 2 times 55 times 72 multiplied by cosine of B. So again, this is just about manipulating your formula. We'll have 25 squared minus 55 squared minus 72 squared, ultimately divided by negative 2 times 55 times 72 in order to get our final value for cosine of angle B. So with that left-hand calculation, we'll get 0.9576 as the approximation for cosine B. So B will be cosine inverse of that decimal. So our approximation for B this time works out to 16.7 degrees. So angle B is roughly 16.7 degrees. Again, to find angle C, you have 2 choices. You can either subtract the 2 calculated angles from 180 degrees, because we know all 3 will sum to 180 degrees. Or if you don't quite trust it, you can take the longer approach and use the third version of our cosine law. So we could go c squared equals a squared plus b squared minus 2ab times the cosine of angle C. So then we'd have 72 squared is equal to a squared, which we know to be 55. So we've got 55 squared plus b squared, or 25 squared, minus 2 times 55 times 25 multiplied by the cosine, again, of angle C. So doing a quick manipulation here, we've got 72 squared minus 55 squared minus 25 squared, and we will divide that, of course, by negative 2 times 55 times 25 to give us that cosine C value. So we get approximately negative 0.5578 as our cosine C value, which means angle C is cosine inverse of that negative number, negative 0.5778. So we've got your ratio there. C works out to be approximately 123.9 degrees. So if we look back at your table here and we fill in that 123.9 degrees, you can sum those angles together. And what you'll find is when you add 39.3 with 16.7 degrees and another 123.9 degrees, you get 179.9 degrees as your total. So again, it's out by about a tenth, but it's because we've had to round as we go. So we've got all 3 angles found using, once again, the cosine law, because we were given 3 sides initially for given information. So that's the end of this section. This is the end of 10.5. So the 10.5 homework questions that you see at the bottom of the slide here will be excellent for practice. So make sure that you are confident and comfortable with the calculator work that goes along with this law. It's not overly complicated. It's just you're using a lot of numbers and manipulating those numbers very carefully in order to solve. So as always, if you have any questions going through your homework, please make sure you make note of them and bring them forward so we can get you some help.